oval, you know the angle between angle ROT is... there's no answer. I need to prove it. I've done it, but it's a long proof.
So
it's not just one answer.
Okay, so let me ask you one by one. Let's read. It's a two overlap.
I got it. Farshid.
Angle
ROT is equal to 180 minus 8x.
Yes, just let me quickly read 3x. Okay. Yes, 180 minus 8x.
Yes. And then because of, the arc TR. The arc in the circle TR.
Let me ask you something. Here you can use one thing to prove it quickly. Have I told you interior angle, exterior angle, inscribed angle, central angle, tangent chord angle? Have I told you these 5 angles before?
No, but I used the arc of a circle.
Yes, okay. So tell me step by step to solve. Okay, what's your next step?
So because the arc TR is 180 minus 8x.
Not the arc, the angle.
Angle.
Yes, the arc is
from TR to the center. To the center. That means any other point which is from that thing, like let's say TQR. So if you make an angle TQR, draw a line from R to Q.
Yes.
Yeah. PQR is half of that. So that is 90 minus 4x.
Yes. Then what?
And then, that's the same as TPR. TPR is also 90 minus 4x.
Yes, good. Let me draw. Yes, then what?
Then I moved our focus to the arc PQ, which is 180 degrees. So that would then mean PRQ is 90 degrees.
Yes.
And PTQ is also 90 degrees.
Yes.
And then because if you look at the triangle SRQ, can you see it?
Yes, 90, 90, 180, so it is 4x.
Yeah.
Yeah, it's completely correct. Good job. Let me tell you one thing. We have 4 different angles. 5. So, central, internal, tangent chord, interior, exterior. So the first...
what? I thought it's obtuse, acute, and right angle.
No. I mean with respect to a circle. Central, internal, tangent chord, interior, and exterior. They are so much powerful and useful. So the first one is central. The next one is inscribed angle, central angle. Here it is tangent, this one is chord. This is a special case of inscribed tangent chord. Angle. It's useful in BMO, JMO, SUMaC, all of them. interior or internal angle.
Who's BMO?
In BMO, they are used.
British Mathematical Olympiad.
Yes, BMO 1, BMO 2. In all Olympiad exams, these 5 are so much used. Okay, let me tell you the first one. If this arc is alpha, what's this angle equal to? You know this central angle.
If this arc is what?
If this arc is alpha, anything, for example, alpha is a variable, x. What's the question
Then
mark?
alpha.
Yes, good.
Then
Alpha.
inscribed angle would be alpha over 2.
Exact. Tangent chord angle.
180 minus.
Tangent chord angle is exactly similar to this one. Look, it is inscribed. This is a special case. It is inscribed, but this one is tangent. Okay.
So alpha over 2.
Again, yes. If this one is alpha, this one is beta. What's this angle equal to?
Alpha.
No, it depends on both alpha and beta.
No, wait. Can I? Huh?
We have A and B, alpha and beta. It depends on both of them.
Oh. 180 minus alpha.
No, let me tell you a hint. Again, here you can draw some lines and prove it. Wanna try it first on your own? You can calculate it. You can connect some points, and like the previous problem, solve it. Try to find the question mark. Okay, draw on a paper and try to find it, connect the points, and use the previous parts, then you can easily find it. Try it.
It's equal to A.
Okay, let me ask you something.
Isn't it? No, wouldn't it be equal to A because it's the same as the central?
No, it's not center. Maybe center is here.
Okay, sorry.
Okay. For example, let me come like this. This is, for example, beta, it is the point. Obviously, center is here. It is not related to the center. It's inside the circle. So what would it be in terms of?
Is it A over 2?
It depends on beta as well.
It's the same as beta.
Let me ask you this.
Is it the same as beta because opposite angles are equal?
No. Let me ask you this. Before that, let me check this one. It is an obvious thing. Suppose this angle is alpha, this angle is beta. What's this angle equal to?
So the one, not that one, the other one, would be 180 minus A minus B.
Yes, exactly. So what's the question mark equal to?
180 minus 180 minus A minus B.
Yes, so what would it be if we simplify it?
A plus B.
Yes, good job. This one is alpha plus beta. So an exterior angle in a triangle is sum of the two non-adjacent angles. It is an important point. Understand?
Yeah, but Farshid, what's alpha?
Alpha is a variable. Usually for angles we use alpha, beta. These are Greek letters. We can say XY.
Is theta an Greek alphabet?
Yes.
Theta.
Theta, alpha, beta, gamma, lambda, all these things. Okay, usually but that's okay to use X and Y. Let me write X and Y. X plus. Okay. Both of them are the same. Now here, and let me ask you this. It is, what's this angle equal to?
How am I supposed to work it out? Because
Look, it is like this one,
it is,
inscribed angle. Look, this is an inscribed angle. This arc is alpha. So what's the question mark equal to?
oh, the whole arc. Oh, okay. Alpha over 2.
Good job. This one is alpha over 2. What's this question mark equal to?
Beta over 2.
Good job. Beta over 2. So what's this question mark equal to?
Beta over 2 plus alpha over 2.
Yes, exterior angle. So alpha over 2 plus beta over 2. So we found this question mark. It's alpha over 2 plus beta over 2, right?
Yeah.
So when we have internal angle, you should see the arcs that it sees and sum of them over 2, okay?
Okay.
Now, the last one, exterior angle. Suppose this arc is beta, this arc is alpha. We want to find this question mark. Try.
Alpha over 2.
No,
Alpha.
it is in terms of alpha and beta. And the proof is something similar to this one. You should create a triangle.
I don't understand how you're supposed to do it.
Want me to tell you should connect which 2 points, or want to find it on your own?
Let me try.
Okay, sure.
Is it beta?
No, not beta. Let me again connect these 2 points, okay? What's this angle equal to?
Which one? I didn't see what you pointed to.
This one.
180 minus A.
No. Look. Alpha is this arc, not the angle. Let me maximize. Look, let me.
That's equal to B over 2.
Exactly. This is B over 2.
And the other one's A over 2.
This one is
so
A
would
over
it be...
So now you can say, because this one is beta over 2, this one is alpha over 2, what's this one equal to?
Oh yeah, because then... wait. B over 2 plus A over 2.
No, you made a careless mistake. Try it again.
B over 2 subtract A over 2.
Yes, good job. Because B over 2 is this one plus this one, so this one should be B over 2 minus A over 2, right?
Yeah.
Or beta minus alpha over 2. So when we have internal angle, you add these 2 arcs. When we have external angle, you should subtract beta minus alpha over 2, okay?
And everything's over 2, yeah.
Exactly. Now let me put a black box, because this is so much useful in all the exams. One of the most useful black boxes that we have. Now we want to use these things to solve this problem quickly, okay? Let me copy. Okay, we want to solve this one again. This is 5x, so it is central angle. So what's arc RQ equal to?
What?
RQ. Arc RQ equal to?
5x.
Exactly. This is 5x. What's this arc equal to?
3x.
Yes. Now this is internal angle. We said in internal angle, we consider both arcs, sum of them divided by 2. So what's this
2.
one? Yes, 5x plus 3x over 2. Finish.
Whoa, that was a lot quicker. Because my lessons with you, you taught me about the circle. I used that way to do it.
Which way?
No, you know how I explained it to you.
Yes. So look, your solution is good. You use angle chasing. But there are some rules, like this black box, then you can use them as a shortcut. So you can quickly find different angles, okay? Because sometimes the problem is harder and you want to find quickly all the angles. Then by internal, external, inscribed, tangent chord, all these things, you can find all the angles quickly, okay?
Okay.